Good afternoon. I'm Anubhav Chawla, team leader of Capstone Group 29. Today, we are here for our capstone presentation. Now, my team members will introduce themselves.
I am Savi Sareen from Electronics and Computer Branch.
I'm Kirti Bhatia from Electronics and Computers branch.
I'm Pratyush Anand from Electronics and Computer Engineering.
I am Arsheya Srivastava from Electronics and Computers.
Parkinson's disease is the second most common age-related neurodegenerative disorder. Speech disorders can progressively diminish the quality of life for a person with Parkinson's disease. The earlier a person receives the baseline speech evaluation and speech therapy, the more likely he or she will be able to maintain communication skills as the disease progresses. The prevalence of speech disorders in PD patients is more than 89%. This is known as hypokinetic dysarthria. The characteristics of this disease includes monotonous and reduced pitch and loudness, breathy and harsh voice. Recent research has shown that speech therapy has proven to be the most efficacious therapeutic method for improving voice and speech function. So we have designed the device which includes an EMG sensor, stereo microphone and a haptic motor. So first the sensor will start working as it detects the throat muscle movement, and then it will activate the microphone which then will start recording it. So all the recordings will be stored for future use in the SD card module, and these recordings will be checked over and over again by the therapist, in which he will compare the sound pressure level with the standard sound pressure level set. So if that pressure level is found to be less than the standard pressure level, then the haptic feedback will take place. That is, and vibration will be sent at the back of the ear. So our device Vaani consists of 4 different modules. Number 1 is the EMG sensor module. Number 2 is the sound sensor module. Number 3 is the haptic motor, and number 4 is the SD card module.
For detecting the sound of patient, we have used LM393 sound detection sensor module, which detects the intensity of sound via a microphone. It comprises an onboard potentiometer to adjust the set point for sound level. LM393 comparator IC is used as voltage comparator in this sound detection sensor module. The comparator IC will compare the threshold voltage set using the preset and the microphone pin.
In Vaani, we have used EMG sensors. EMG stands for electromyography. It measures the electric response of the muscle. The sensors will be placed behind the patient's neck area below the ear. When the patient starts speaking, there will be a movement in the spadius muscle. The sensor will detect the movement and send the signal to the microcontroller. Now, the microcontroller will detect and forward the signal to the microphone for its activation.
As soon as the microphones are activated by the microcontroller, the module 3 of our project will start working. 3 of the project includes haptic feedback through vibrational motor. Microphone will take audio input and will send it to microcontroller. This microcontroller will compare it to a threshold value set by the therapist. If the value received by microphone is less than the threshold value, a noticeable vibration will be sent to the patient, indicating that he is speaking below a threshold level.
We have used the SD card module, which allows us to communicate with the memory card and write or read the information in it using the SPI protocol. It is a non-volatile memory in which you can store still images, videos, files, etc. Intellect. We have plotted the sound level intensity of the stored values in the SD card. It operates in the region of 4.5 volts to 5.5 volts.
So this is our EMG sensor. Second is our sound sensor module. Third one is the haptic motor. And fourth one will be the SD card module. The sensor will be placed like this on the muscle below the ear and near the throat. Now second is the sound sensor module. It is placed like a mic near the mouth. Third is the motor, which will be placed behind the ear of the person, and this whole circuit will be in a box which will be as a belt pack with the person. Now as I am speaking, the motor will not vibrate. As you can see in this video, when the person is whispering so loud, the motor starts vibrating.